All right, probably the most important problem of the unit. Unfortunately, probably also the trickiest to understand. So here we go. Find the instantaneous slope of the function f of x, of the instantaneous slope of the function f of x when x is 2. Well, let's figure out where we are when x is 2. So when x is 2, what's y? We'll find f of 2. F of 2 is going to equal 3 times 2 minus 4 squared plus 2. 2 minus 4 is negative 2. Negative 2 squared is 4. 3 times 4 is 12. 12 plus 2 is 14. So this is telling me that I have a point 2 comma 14. And I want to find the instantaneous slope, which means I need to write a slope equation for this. Here's a point that I want, x1 comma y1, the interesting point that I've been told. The other point needs to be generalized, which means we need to write an expression that could represent any point on this graph. Well, any point could be represented with an x as the x value, and then the function as the y value. So 3 times x minus 4 squared plus 2. This way, choose an x value, plug it in, and you get x, comma, whatever the y value is, because you're using the function. So let's label this as an x2 and a y2. So we have 2 points, x1, y1, and x2, y2, and we want to find the slope between them. Well, slope, m, is y2 minus y1 over x2 minus x1. And let's plug in the things we found. Well, y2 was my function. So 3 times x minus 4 squared plus 2 minus y1 is the y value of my point, which is 14, all over x2, which is just x, minus x1, which is the x value of my point, 2. Okay? So think about what this expression is. It is function minus y value divided by x minus x value. Okay? That's always how you're going to be able to find the slope generally from any x value on your graph to a fixed point on your graph. Okay? Well, what now? Now let's simplify things. First off, a plus 2 and a minus 14 can be written as a minus 12. So I've got a 3. X minus 4 squared, I'm going to expand. So that's going to give me x squared minus 8x plus 16. Close it. And then I have my minus 12 over x minus 2. Can't do anything with that. Okay. Well, what do we want to do? We want to find the instantaneous slope, which means we need to look at the limit as this thingy approaches 2, because we're interested in the x value of 2. Can you plug in 2? No. 2 minus 2 in the bottom is 0. In the top, 2 squared is 4. Minus 8 times 2 is 4 minus 16 plus 16. Well, the 16s go away. 3 times 4 is 12. 12 minus 12 is 0. Indeterminate form, sadness. So we need to do some work. Okay? Couple ways you can handle this. Well, one way is you could incorporate that negative 12 into that stuff in the parentheses. If you do that, you need to remember that that negative 12 is really a 3 times a negative 4. So what that means is you could rewrite this as 3 times x squared minus 8x plus 16 minus 4 would be the same way. Because look, I would have to distribute the 3 to the minus 4, giving me that original minus 12 that I had. That's over x minus 2. That's a 2, I promise you. It looks like a 12. That's a 2. Okay, that's a 2. Well, and then what could I do? Well, 16 minus 4 is 12. So that top is really, that's really an x squared minus 8x plus 12. And then we could factor it. So x, our slope m equals 3 times x squared minus 8x minus, plus 12 factors as x minus 2 times x minus 6. Divide that by x minus 2. Well, look, whole, take it out. So we need to look at the limit as x approaches 2 of 3 times x minus 6. Now we can plug it in. 3 times 2 minus 6 gives you negative 12. And negative 12 is our instantaneous slope at the point, or at the x value of 2. Let's talk about another way we could do this. At this point, once we've written our slope and we're starting to expand it, let's just fully expand that thing, right? So let's say, I'll do a different color. Let's say 3x squared minus 24x plus 48 minus 12, all still over x minus 2. Let's combine the 48 and the minus 12, so we're dealing with 3x squared minus 24x plus 48 minus 12 is a plus 36. It's all over x minus 2. Well, again, think about the problem. It's the same problem we've had this entire unit. There's a hole and we want to take it out. And we just did it by factoring, but you could also just divide, right? Use some synthetic division. Divide by 2 our function, which is 3x squared minus 24x plus, I shouldn't write that plus, but plus 36. And just do some synthetic division. Drop the 3 down. 2 times 3 is 6. Negative 24 plus 6 is negative 18. And a 2 times negative 18 is a negative 36, giving us a 0 happy remainder. So this is telling me that when I factor out that hole, when I take out that hole, x minus 2, I'm left with 3x minus 18. So we can just look at the limit as x approaches 2 of 3x minus 18, which you could just directly plug in. What's happening? Weird. Directly plug into 3 times 2 minus 18. Lo and behold, 3 times 2 is 6. 6 minus 18, again, gets me negative 12. The instantaneous slope there. Look, 3 times x minus 6, that's just a factor version of 3x minus 18. Boom.